Okay, let's go over our test. And so this is problem one. This is the formula. And to answer the first question, that number, that negative 4.9, is half the acceleration due to gravity. And you need to know, you should know, in my opinion, you should know that if that was negative 16, we're working in feet and seconds. So the time would have been in seconds and the height would have been in feet. But if it's negative 4.9, that's half of the acceleration due to gravity in feet per second, which is negative 32 feet per second squared. But in the metric system, it's negative 9.8 meters per second squared. And so you would see half of 9.8, negative 4.9, and know that we're working with meters and seconds. And so the answer to the first one here, since it's negative 4.9, the time is in seconds, and the height is in meters. So if I'm supposed to determine the height at 7 seconds, 0.7 seconds, I need to put 0.7 into there. Now, some of you had trouble putting 0.7 in there. I'll type it in my calculator, negative 4.9, parenthesis, 0.7, close parenthesis, squared, excuse me, plus 20 parentheses times 0.7, close parenthesis, plus 8. And I get 19.599. 19.599. 19.6 rounded off to 3 decimal places, and that height would be meters. H is in meters. Now I'm going to do it a different way. I'm going to go to my y equals, clear, and I'm going to type in the equation, negative 4.9 x squared instead of t squared, plus 20x instead of t, plus 8. And then I can go, if I have my table set on ask, I went to table set, this one right there, and said ask, and then I'm going to go down over to my table, second graph, and I can type in the numbers I want to put in. So I wanted to put in 0.7, and it said 19.599. I can put in 1.2, and it'll tell me it's 24.94. 24.9 is close enough. And to show my work, I would negative 4.9 times 0.7 squared plus 20 times 0.7 plus 8. And I would write the same thing with 1.2 instead of the 0.7. Now I need to know when the height is 12. Well, I could keep guessing around here for what number might make it come out to be 12. See, 0.7 wasn't enough, or was too much. Maybe 0.5, and it says, no, that's too much. 0.2 says, that's too little. 0.21, that's closer. 0.22, that's a little too much, and so I can estimate it that way. Or I could go to my graph. Now let's make the window correct. So I'm going to deal with time, and we're going up. If something's thrown in the air, it's not going to be in the air very long. And it's not going to be in negative time, so I'm going to go from 0 to maybe 6 seconds. And it's not going to be any lower than 0. It might get up to 22 meters. Don't know. But I'll push graph and see what happens. Oh, it went higher than 22. But so the window was at 22. What I want to know is when this is at 12. Now, you can type these two into Desmos and just tap where the lines intersect, and you'll have the answer. On a calculator, you go second calculate, second trace button, and find the intersection. That's option 5. Press enter, and it'll ask me, is the blue equation, the blue graph, one of them? And I'll press enter for yes. Now it's asking, is the red equation one of them? Yes. And then it says, what's my guess? And I'm just going to move kind of close to this one over here, closer to this one than the other one. And it says, oh, 0.2108. So 0.21. And that's for the t. And t is in seconds. So at 0.21 seconds, the ball is on its way up and reaches 12 meters. And then on the way down, it gets to 12 again. Let's go there. Second, calculate. Option 5, the intersection. And is that blue curve one of them? Yes. Is the red curve the other one? Yes. And where is it that I want to look? And that happens to be way over here. I could type in a number too, but I'm just going to move it over there. And it says, oh, 3.87. Now, some of you decided to do the quadratic formula. We want a negative 4.9 t squared plus 20t plus 8 to come out equal to 12. To use the quadratic formula, you need it equal to 0, so you subtract 12 from both sides. And you get minus 4.9 t squared plus 20t minus 4 equals 0. And then the quadratic formula says the opposite of b plus or minus the square root of b squared minus 4 times a times c. All of that is divided by 2a. All right. Now to type that in on a calculator, there's a lot there, and you got to be kind of careful. So I'm going to type in parenthesis, because I need to hold my numerator together, negative 20 plus square root 20 squared, subtract 4 times negative 4.9 times negative 4, and I'm using the negative, not the subtract. Got to close this, and then divide by parenthesis. You got to hold that denominator together. 2 parenthesis negative 4.9, close parenthesis, close parenthesis. And I get the 2.108 that I had before. And then if I go back up here, the thing that's got to change is not the plus, but the minus on the square root. And I get the 3.87 that I was supposed to get. Okay, that's hard to see there. Oh, maybe that's better. Okay. Explain the meaning of what we found in D. We found T, the times actually, for when the ball reaches a height of 12 meters on its way up and on its way down. And they both were seconds. So what does h of 1.2? Well, h of 1.2 is the time, and h is the height in meters. So I'm taking the height at 1.2 seconds and subtracting the height at 0.7 seconds. So when I'm subtracting, I'm finding the difference in the heights. The difference or the change in height. Between 0.7 seconds and 1.2 seconds. Number 2. First, there's 50 there, there's 0 there. If I were to try to be careful about this some way, it looks like from the edge of the rubber on my pen to the top matches this dot, and you notice that the rubber to the point of my 10 matches it to the bottom. So this has got to be halfway between 0 and 50, or 25. And so if that's 25, this might be like 30. If that's 30, 40 must be halfway between. And the same amount down here has got to be 20, and halfway between 10. And those look pretty even. So that looks like the units. There's a little bit of skill in just being able to read a graph that doesn't have very good units on it. But that's what the actual scaling was. Now, if you chose this to be 30 and called that 20, a 34 or something, I use those numbers, but that's the idea. So now, which line was the horizontal line? That turned out to be the blue car. So this is the red car. The blue's velocity, determined the velocity of the blue car, it never changed. It was always 30. 30 what? Velocities are in miles per hour. So we need to put the units, miles per hour. Acceleration, that's the slope of the velocity. For the red car, so that's the slope of the red line. Now, if I'd asked for the blue line, the slope would be 0 because it doesn't rise or fall. But for the acceleration of the red car, it looks like it goes from 25 to 30. So that's a change of 5 miles per hour, because that's the units this way, in how much time? Well, the change in time was also 5, but this case it's hours. So we get an average, approximated average acceleration of 1 mile per hour faster every hour. Let's see if that makes sense. In 1 hour, it should be going 1 mile an hour faster, so 25 to 26, 27, 28, 29, 30. That makes sense. Okay. Determine the distance after 2 hours for the blue car? Well, the blue car is always going 30 miles an hour. So it's going to go 30 miles in the first second and in the first hour and 30 miles in the second hour. So it's going to go 60 miles. The distance is measured in miles. If the cars start at the same place, so imagine they're both starting here, and let's say this is the red and this is the blue, which one is going faster to start with? Well, the blue is going faster, so it might get this far and the red's going to be behind. A fair amount behind because it's going 5 miles an hour slower. In 1 hour, they'll be behind by 5 miles. And after 2 hours, it wasn't going 5 miles an hour slow the whole time, so it won't be 5. It'll be a little less than 5. But the next one, it's going to be more like 4 behind. And then 3 behind, 3 more behind. So it's 1 behind, and then 5 behind, then 4, and 3 and 2. So it's 5 behind plus 4 behind. That's 9 plus 3. That's 12. It's getting pretty far behind the blue car by the time it gets to 5. So by the time it gets to 7, it's going to make up maybe a mile and then maybe 2 miles, but it's not going to get caught up to blue until maybe out here at 12 or at 10 hours. So the leader has to be blue. Page 2. When you're reading a ruler, you always measure you don't say that's 1 inch, you say from here to there's 1 inch, and from here to there's 1 inch. And since there's 4 of these spaces, we say there's 4 of those in an inch, and each one is 1/4. And these little marks are for 16th. It doesn't mean that's a 16th right there. It means the spaces are 16th. And so you need to count the spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oop, I didn't count right. 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 8s. Now I got to make sure I did that right. It's kind of hard where I had it, so I'm going to have to move it so I can see better. 2, 4, 6, 8 spaces. 10, 12, 14, 16, 18 spaces. Each space is a 16th. 16th. So that reduces to 2 goes into both 9/8 inches. And a quote is in measuring is considered inches. So it should have been 9/8 inches or 1 1/8 inches. You can also write out inches. Okay. So if you're going to fold up a piece of paper to make a box, you got to fold up each side. And if the amount you're folding up is 1 3/16, you're taking away from the width 1 3/16 and you're taking away it twice. So what is 1 13/16 plus another 1 13/16? Well, 1 and 1 is 2, and 13/16 plus 13/16 is 26/16. which reduces to 13/8. So it's 2 and 13/8, but that's 1 and some extra 8s. So we're going to get 2 plus 1, or 3. And so that would be 5/8 left. So now the length would be the 20 inches minus 3 and 5/8 inches. So it's going to be 20 minus 3 would be 17, but we'd still have to take away the 5/8. And if I borrow a 1 and make it 16, and then I'll have 8/8 minus 5/8, which is 3/8. In case you're having trouble with fractions, I hope you understood that. And the width, which is 14 inches minus 2 of these 1 and 3/16 minus 3 and 5/8 inches. So I end up with 3 from that is 11, but then I got to take another one away to take the 5/8 from, and so I'm going to get 10 and 3/8 inches, borrowing just like I had to borrow here from the 11 to make it 10. And the height is just going to be how much I fold up, which is 1 and 13/16 inches. Notice I'm showing my units, please. And the volume is going to be inches times inches times inches. So it's going to be inches cubed, not inches squared. I'm multiplying 3 units. So I'm going to take these 3 numbers and multiply them. Now, you can do it on a calculator. You can do it on your phone. You can do it on a lot of different things, but I'll clear this. So I'm going to take, so you know how to type it in. It's 16 plus 3 divided by 8, close parenthesis, times 10 and 3/8, 10 plus 3 divided by 8, times 1 plus 13 divided by 16, close parenthesis, and that works out to be this in decimal, 307, that's close enough, 307.9, 308 inches cubed. Now, if you wanted to have that in a fraction, you should know how to do that on a calculator. And on a TI, you push math down here, math, convert it to a fraction. Enter, enter. And it says, oh, it's 315,317 divided by 1024 inches cubed. But I accepted this answer, a decimal approximation of that. So now the formula for v of x, and you should write that when you're writing a formula for a function, is the 20 minus 2 times however much we folded, and we're leaving x so that we can have a formula for it, the changes, and then 14 minus 2x, and then the height was just whatever we folded up, x. Now, if I use technology for this, I'm going to do parentheses 20 minus 2x, close parentheses, open parentheses, 14 minus 2x, close parentheses, open parentheses, times x. I don't even have to put the parentheses on that last one. And now if I try to graph this, I'm not going to see very much. Now the amount that I can subtract is going to be somewhere between 0 and, let's see, the paper's 20, so it couldn't be more than 20. And the volume has to be somewhere between 0, but I'll put minus 10 up to, let's see, well, we got an answer of 307, so I must need to go like 400. And then I'm going to push graph. And so the volume goes through 0, gets up to some height, back to 0, goes negative, come back to 0, and goes on up. And it says, use technology to determine the x that yields the maximum volume. So we want to know where an x gives us the maximum volume. Now we're not going to use over there because it's not possible to fold that big a side because the paper's not long enough. This is folding 1 inch up or 2 inches, 3, 4, 5, 6, 7 inches up. Why is 7 a limiter? Well, it's half of 14. If we fold the paper in half this way, the most it can be on each side is 7. So that's kind of the limit of what we can do. So we want to find that maximum. And if you're using a calculator, the way to find maximum, I'm trying to find a spot of work here. I'll go second calculate the max. And I can say it asks for a bound. Where is that max at? Well, it's somewhere between 0 and 7. So I'm going to type in it's between 0, enter, and 7, enter. And it asks me for a guess. I'm going to guess at 3 inches. And it says, no, you're full of baloney. It's 2.7. So at 2.70 something inches, we should fold that up to get the most volume. And the volume we would get is 339 cubic inches. We were pretty close. We had 307 in our guesstimate, the guesstimate that I made you calculate. But we were close to it, but not the right amount. So what do the x-intercepts mean? Well, there's 3 of them. 0, 7, and 10. Okay? So x equals 0, no volume, because you're not folding it, not folding any side up. Box can't hold anything if it doesn't have sides. How about x equal 7? That's folding one half of the 14 inches, leaving the bottom width equal to 0 inches. And the last one, the 10, this is folding half of the 20 inches, the other direction of the paper, leaving no length for the bottom. Okay. Determine the situational domain. Well, anything over 7, we can't fold it anymore. If you only got 14 inches and you try to fold it up, the most you can fold up is 7 and 7 and make a box. So you could fold up anywhere from 0 to 7. You could for sure do 7. Doesn't give you any volume. And I suppose you could say you could for sure fold nothing. But you couldn't fold up a negative number, and you couldn't fold up more than 7 because it wouldn't be a box. You can't fold more than 7 on the width. And what's the situational range? Well, what answers will you get if you go somewhere between 0 and 7? Well, you'll get a volume of either 0 up to the max, which is 339. Then you can get up to that 339. Okay? Hopefully that'll help you on that one. All right, now let's be careful about this. If we've got a vase that's the same size all the way from the bottom to halfway up, and we're pouring water in at a constant rate, it's going to fill pretty quickly. And it's going to fill at a, after each second, it's going to be going up the same amount. So every second of time, it's going to be going up the same amount. But if the vase starts to spread out, it's going to have to slow down. And here it's kind of skinny, and here it's getting pretty fat, and so it's going to slow down more and more and more. Well, the speed is the slope. If it's going up pretty steady, that slope is going to start tailing off, slowing down. So it should be straight till halfway, and then it should curve, taking more time to fill the rest of it. Now in this one, since it's kind of skinny at the bottom, not as skinny as this, it won't go up as fast as this one did to start with, but it'll go up kind of fast. But as you get out here and gets wider, it's going to slow down how fast it's going up. So it's going to take more and more time to move up little amounts. So it's going to curve in here. And then when it gets to here, it's going to start speeding up. And so it's going to speed up gradually, so it's going to curve up. So this should match here, and this should match the top, and it takes so much time to get to the halfway, and then probably the same amount of time, since it's the same size, for the last part, but curved down, starting fast, going slower, and going from slower to faster in the end. Now this one, it's going to start pretty slow, and as we go, it's going to pick up speed till we get to here, and then it's pretty uniform, and so it's going to go at the same speed the rest of the way. It's the same shape going here, so as you pour it, for every second, it's going to go up the same amount. So it's curved at the beginning, straight at the end. All right. Time to be watching your units. I'm going to write 25 miles per gallon. And I'm going to write 65 miles per hour. So if I multiplied 25 miles per gallon by gallons, I'd get miles. So if I give this one gallons and multiply it by this, I get distance. Which one takes gallons and turns into distance? Gallons to distance. So I'm going to take the gallons, G, times 25, and I will get a distance, M, or D in miles. If I take this one, which is miles per hour, if I take it times hours, which is a time, I will get miles. So which one says multiply by time and get distance? Well, distance from time, this would have to be 65 miles per hour times the number of hours, T, will give me the distance. Notice I'm really focusing on the units. So, this is D of T. What if I wanted to do T of D, turn these around? That would be inverses. So just like we did Y equals something X, I'd think of this as Y equals 65X, switch the Y and X, but in this case, D and the T, so I'd put, this was D, so I'll make it T and make this D and solve for, oops, I don't want to do it that way. That's going to confuse you, sorry. This is D equals 65T. So if I solve for T, I'm going to divide by 65, and T, to get the time, I would take the distance divided by 65. Well, if I take this says, given the distance, can you find the time? And so I find the time by taking the distance divided by 65. To find, let's turn this one around. It says the distance is 25G. So G, dividing both sides by 25, is D divided by 25. So is there a function that gives me, I give it D and it finds G. I give it D and it finds G. So this one has to be D divided by 25. Now I need to come up with one that I give it a T and it gives a G. Well, this one I have to give a D. This one I have to give a G. This one I have to give a D. This one I have to give it a T. Well, I have to start with a T. The only one that starts with a T is this one. So that would be 65T, but that returns D. So then I have to put D into something that'll give me G. Well, D gives me G if I put D, which is what this was, divided by 25. Hopefully you can look at the units and now decide what the equations had to go where and figure out the composite. This could have said T of G. It might on the retest. All right, now we're supposed to determine the domain for these. So I'm looking for trouble. It sounds like somebody wanting to fight. No, I'm looking for what might cause trouble, and that's square roots of negatives, or fourth roots, even roots of negatives. That would be trouble. And division by 0, that also would be trouble. Do I have any division in this problem? No, so I don't have to worry about dividing by 0. But I do have a square root, and the inside of the square root can't be negative. Now, I could graph this whole thing. Let's do that. I'm going to show you a couple ways to look at this on a calculator, see it. One would be to type in, and you can do this on Desmos, plus the square root of 4 minus 2x. And if I just go standard screen, zoom 6, I have a graph that looks like I can use any of these x's and get an answers, but they die somewhere around 4. So 1, 2, 3, 4. I must have typed something wrong because it shouldn't. Oh, I forgot to do 2x. I'm looking at that and saying I did something wrong. Okay, now, because it should die around 2. Why does it die around 2? If I put 2 in here, 2 times 2 is 4. 4 minus 4 is 0. I can take the square root of 0. So 2's okay. Now the question is, can I use numbers below or above? Well, it says I can use the numbers below. Less than 2. So the numbers have to be less than or equal to 2. So in set builder notations, the set whose elements are numbers such that the numbers are less than 2. Or reals less than 2. Or in interval notation, negative infinity up to 2, including 2. Less than or equal to 2. Forgot the equal. Now, I'm going to do another one. Do this one a different way. I'm going to go to here. The only part I'm concerned about is 4 minus 2x being negative. So I'm just going to type 4 minus 2x, and I'm going to get rid of the other one. And I don't want that to be negative. Well, it's negative from 2 on, so I don't want those. It's positive otherwise. From negative infinity up to 2, it's positive or 0. After that, it's negative, and it can't be negative, so I don't want those numbers. Showed you a couple ways to work with those. Now let's do it algebraically. We want 4 minus 2x to not be negative. We want it to be greater than or equal to 0. That's not negative. Now, some of you did this, and then you subtracted 4 from both sides. Some of you forgot to write minus 4 and messed it up. And then you have to divide by a negative. And I spent quite a bit of time in class talking about if you divide by a negative, there's a reason that you have to turn the sign around. And if you forget to do that, you're going to get the wrong answer. And a negative 4 divided by negative 2 is plus 2. And we end up with what we knew before. X has got to be 2 or less. Less than or equal to 2. Okay, R. Well, there's 2 things we got to watch out for. Square roots of negatives or division by 0. Here's division, so we got to watch out for this being 0. Can 2 minus x come out to equal 0, which we don't want? Well, I could subtract 2 from both sides. Divide by negative 1. Or multiply by negative 1. So this is all reals except 2. Or from negative infinity to 2, not including 2, union from 2 to infinity. That skips over the 2. Or I could say the set whose elements are the numbers such that the numbers are not equal to 2 in set. 3 different ways to write the answer. All right, here we have both devils, both problems. We have a square root, x squared plus 1. We don't want that. Okay. We don't want the x squared plus 1 to ever be negative. Oh, look, It never is negative. No matter what I put in for x, negative numbers or positive numbers, and square them, I will either get 0 or a positive number, add 1. This will never be negative. So I don't have to worry about the square root being negative. Does the square root ever become 0? Because that would be division by 0. Well, look at this. What's in there is never 0, so the square root of that, and if you don't believe me, we can go on here and go second insert square root. Oh, and that's got to have all of that in there, so I better just clear and go square root of x squared plus 1. And if I graph that, does it ever go negative? Let's go back here so because that screen doesn't show up there. There. Is it ever negative? Never. So I don't get 0 in the denominator, and I don't get a negative in the square root. So that means I can use any number. This graph will show up everywhere. All reals. Or I could say from negative infinity to infinity. Any number works in there. I could actually graph the whole thing. I can say this, in front of it, we have a parenthesis 2x minus 5, close parenthesis, divided by. Let's graph it, the whole thing. Notice that for every x, there is a y value. It can calculate that one. Now there could be a hole that we have a hard time seeing, but we've already kind of checked that and saw that there is no holes. Okay, now we got composite functions, and we got to do domain and range on composites. And there's a way to do those on a calculator and on Desmos. I'll show it on the calculator, and hopefully you'll be able to understand how to do it on Desmos. But the idea is you have to be able to put the number into f. Well, we've already found out that you have to use a number less than 2 or equal to 2. So we're only going to be able to use in f those from negative infinity to 2, including. But when I use those, what comes out has to be able to go into R. And we can't use 2 in R. So of all these numbers, if any of them produces a 2, we can't use it because we can't use it in R. So we have to look at f of x and see if there's an x that will make 1 minus the square root of 4 minus 2x come out to be 2, the number we can't use. So this can't equal that. So now let's solve this. So I'll subtract 1 from both sides. And I have minus the square root of 4 minus 2x cannot equal, subtracting 1, I get 1. Multiply both sides by negative 1, and I get square root of 4 minus 2x cannot equal negative 1. And if I square both sides, I get 4 minus 2x cannot equal 1. Subtract 4 from both sides, and I get minus 2x cannot equal minus 4, negative 3. And if I divide by 2, x cannot equal negative 3 divided by negative 2, which is negative 1.5 or positive 1.5 or 3/2. So we had to be somewhere between negative infinity and 2, and we can't be there. Well, that is between there, so we have to throw that out. And so our domain for this one becomes from negative infinity up to 3 halves, and then skip over the 3 halves and continue on up to 2. And we can use 2. That's the domain of this. Now, I promised I'd show this on the calculator. So I'm going to go here, and I'm going to type in f of x. So clear, it's 1 plus the square root. Let's see, put it someplace where you can see it well. Let's try there. 1 plus square root of 4 minus 2x. That's f of x. Now in Desmos I'd write f of x equals this. Then I'm going to go down here and do a different one. In Desmos I'd write r of x. And here I'm just going to call it y2 is, and r of x is parenthesis x plus 2, close parenthesis, divided by parenthesis 2 minus x, close parenthesis. And what we're looking for is y1 put in place of the x's in y2. F of x in place of the x's in y2. So I want to do just what it says. And the calculator knows function notation. I want to do, and this is found under vars. I'm going into vars. Vars, y variables, I'm going to r, which was y2, of y1. Vars y1. Close parenthesis. y2 of y1. And you could put of x, but this is good enough. And I should be able to graph this. Okay, so what happened? This was y1. This is or f of x. Let's move it here so you can see it a little bit better. There we go. This was f of x, the blue one, the first one. The blue one. The red one is r of x. And notice r avoids 2. And that's what we said. R of x can be everything except 2. So it's over here and it's over here, but it misses 2. Now, what does r of f of x equal? Remember, that was y2 of y1. And it misses, it comes along and it skips over 1.5 and then comes back here and starts again, but then stops at 2 because f of x has to stop at 2. So we have all this up to 1.5 in there. Let me even show you. I'm going to go second, draw a vertical line at 1.5. And there's close to it. And do you see how the black went down and avoided that, and then it came back on the other side of it, but it didn't hit that vertical line. Okay, I think I can go 1.5 and it'll draw. Oh, nope. Anyway, I can go here. I have to go to here. Let's see. I push second, draw vertical line at 1.5. Let's see if that does that. Nope. I've forgotten how to do it, but we could draw a vertical line, but we saw it working there. Okay? So now the final one. We could do it on a calculator, but let's just think about this. The inside, instead of saying f of x, I made up a new function. It's like y equals x squared. What can x squared take? Well, you can square any number. So this will accept all real numbers. Then they have to go into h. Well, what can h take? All real numbers. So anything you got out of this, h can handle, and so this is all real numbers, or from negative infinity to infinity. That one turned out to be kind of easy. The hardest one was D. Okay, back page. Those were the hard problems. Now come the easy problems. At least I think they're easy. You may not. Says put 1 into f. Well, that would be 4 minus 5 times 1. And 4 minus 5 would be minus 1. So f of 1 is minus 1, so I got to do h of negative 1. Well, negative 1 goes into h and turns out a 2. So it went from this, f of 1 is minus 1, and then h of that minus 1 is 2. This says subtract. This says f of minus 2 subtract g of minus 2. So if I put minus 2 into f of minus 2 would be 4 minus 5 times a negative 2. So that's 4 plus 10, 14. So I got 14 minus g. G of minus 2 is 1. So 14 minus 1 is 13. C says find the y height in K. K is the graph picture. The y height is 3. What's the x? K of what x is 3? Well, K, the y height, is 3 when x is 4. This says find g of 0. Well, 0, g is 3. So this turns into k of f of 3. Because g of 0 is 3. So now what's f of 3? So I got to put 3 in here, and I get f of 3 is 4 minus 5 times 3. 5 times 3 is 15. 4 minus 15 is negative 11. So this becomes k of negative 11, which, if I go to the graph, this has got an arrow, so it continues on. So k of negative 1 is negative 2. Negative 2 is negative 3. Negative 3 is negative 4. The y value is always one more negative than the x value. So this is going to be negative 12. K of negative 11 is one more below negative 11, negative 12. Now we have to do f inverse. That's where we replace the f with y. Swap the y and x. So it becomes x equals 4 minus 5y. And then solve for y. And y will be the inverse function. So we subtract 4 from both sides. So x minus 4 equals negative 5y. And then we divide by negative 5. And we get y equals x minus 4 divided by negative 5. Now you could call it negative 1/5 x plus 4/5. You could divide them both by negative 5. G backwards. Well, G takes negative 2 and makes it 1. So backwards, it will take one and make it negative 2. It would takes negative 1 and makes it 2, so backwards it would take 2 and make it be negative 1. And it would take 3 and make it 0, 0 and make it 1, and negative 1 to make it be 2. And I have no repeats, so this is a function. G must have been 1 to 1, and so this is okay. And there's my answer. Now let's do H backwards. So I got x and H inverse of x. And minus 2 goes to 3, so backwards 3 goes to minus 2. 2 goes to minus 1. 1 goes to 0. Oop, get it here so you can see it. And 4 goes to 1. And 3 goes to 2. Oops. We've got 3 going to 2 different answers. It wasn't 1 to 1, so it doesn't have an inverse function. So there's no inverse. Now this one. This one says, what does G inverse do to a 3? What a G inverse changes it to 0. So this becomes f of 0. And what's f do to 0? Well, it makes it 4 minus 5 times 0, which is 4. All right, last one. Determine the inverse. It's straight from here to there, so use that. What's this point? And some of you a little trouble with graphing, but it's minus 2 and up 7. So I'm going to find that one switched. I'm going to find positive 7 minus 2. Positive 7 minus 2. And I got to connect it with a straight line to this point. Well, what was this point? That's minus 1 minus 3. Negative 1, negative 3. So I got to connect this to the inverse of this. So it's going to be negative 3, negative 1 with a straight line. No curve here. This part was straight, so its reflection, mirror image, will still be straight. We don't have a warped window, and it's a reflection over the y equal x line, this line. So this part's mirror will show there, this part will mirror to there. And then, let's continue a little further. It's curved till about here. So I'm going to find that point. That's 1 minus 4.8. 1 minus 4.8. So I got to find minus 4.8, 1. And that part is curved. It comes right off that long straight line with a nice natural bend. Straight line with a natural bend. So this is minus 4.81. And then it's straight clear to there, which is 6 minus 5.6. 5.5, something like that. So the inverse would be minus 5.66. Minus 5.66. And from there to there, it was straight line. So from where that one and that one are, it's a straight line. And if you want to check yourself, you should be able to take the paper and fold it on the y equal x line, and it should match up. This should match this side, and this should match that side. If you look at it from one side to the other. If you fold it on y equal x line. Little something I didn't show in class, but might help you. In fact, if you hold it up to a light and look through the paper, you should see the lines lining up on each other. It's a little tricky to do, but you can do that to check if you got the inverses right. Okay.